Hey guys, this looks like a fun one. We're given two small rectangles are congruent and each have an area of 12. And it wants to know what is the area of the larger rectangle. This is day 25 of the 2025 Advent calendar. And if you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. First, let's label the smaller side of these orange rectangles X. This one will also equal X. And then we can label the longer side of the two rectangles Y. So this one will also equal Y. And we know that the area of each of these rectangles is equal to 12. So the base times height, X times Y, is going to equal 12. This looks important. Let's put a box around it. And then for the larger rectangle, we can label this side A, and that'll be the same as this side A. And we can label the longer side B. We can also write a formula for the area that we're trying to solve. It's going to be equal to A times B. This also looks important. Let's put a box around it. We're trying to solve for A and B. Next, we don't really know anything about this side. Let's label it Z. And then this piece here is going to be the whole thing Y minus Z. Now, since these are all rectangles, this is going to be a right angle, this is going to be a right angle, this is going to be a right angle, and this is going to be a right angle. And then if we focus on this triangle right here, let's label this angle green and this angle yellow. We know the yellow plus 90 plus green has to equal 180 degrees because that's the sum of the interior angles of a triangle. So we also know the yellow plus 90 plus this is equal to 180 degrees. That means this must be a green angle. And then in this triangle, we have a green angle and a 90, which means the last angle has to be a yellow angle. Let's look at these two triangles and copy them down here. And we can rotate this one like this. Now, since the two triangles have three pairs of congruent angles, we know they're similar. That means we can set up a proportion. It's going to be base divided by height equals base divided by height. So it's going to be X plus Y minus Z divided by Y equals X divided by Z. And then from here, to get rid of the denominator, we can multiply both sides of the equation by ZY. Do ZY. And then on the left-hand side, this Y and this Y are going to cancel each other out. And the Z is going to distribute to each of these three terms. It'll give us ZX plus ZY minus Z squared. And then on the right-hand side, these two Z's are going to cancel each other out, leaving us with XY. And now we ran out of room, so let's clean all this up and bring this up here. From here, I want to try to do some factor by grouping. Let's set it all equal to 0. We can subtract XY from both sides. On the left-hand side, we'll have ZX plus ZY minus Z squared minus XY. And then on the right-hand side, these will all cancel out, leaving us with 0. Let's rearrange the terms like this. And then we can factor by grouping. The first two terms each contain an X, so let's factor out an X. And then for the third and fourth terms, each of these contains a Z, so let's factor out a Z. And let's subtract the Z. I think that's going to work out right. For the first one, after we factor out an X, we'll be left with Z minus Y. And then for the second one, after we factor out a negative Z, we'll be left with positive Z minus Y. And this whole thing is still going to be equal to 0. Now we have two terms, and each of these terms contains a Z minus Y. So we can factor out Z minus Y. And then to get inside this parentheses, we're going to factor out this Z minus Y to leave us with X, and then factor out this Z minus Y to leave us with negative Z. And this will still be equal to 0. And then anytime you have something times something equals 0, it's going to be true if either of those somethings is equal to 0. So we can say Z minus Y equals 0 or X minus Z equals 0. This will be true if Z and Y are the same thing, so we can say Z equals Y. And this will be true if Z and X are the same thing, so we can say Z equals X. Now we can test out the two scenarios. If Z is equal to Y, this whole distance would be 0, but the diagram is defining this as a non-zero distance. So this one is not a valid solution. And then let's test the scenario for Z equals X. That means this Z would be X and this would be Y minus X, which seems totally valid. So I think this is a valid solution. Let's do some substitutions. In the place of both of these Z's, we can plug in X. And now we're done with Z. Goodbye, Z. And now we know this whole distance. It's going to be equal to X plus Y minus X. This positive X and this negative X are going to cancel each other out. So this whole distance is equal to Y. And now since this is 90 degrees and this is X and this is X, this is a 45, 45, 90 triangle. And same thing right here. Since this is 90 degrees and this is Y and this is Y, this is also a 45, 45, 90 degree triangle. Let's look at these notes for 45, 45, 90 degree triangles. It says the hypotenuse will always be the side length times the square root of 2. So for this one here, this hypotenuse A is going to be equal to the side length X times the square root of 2. So a is equal to x root 2. And same thing for this right triangle. We can bring the b down here. This hypotenuse b is going to be equal to the side length y times the square root of 2. So we know b is equal to y root 2. And now we have values for a and b. Let's plug them into these notes right here. In the place of the a, let's plug in x root 2. And in the place of the b, let's plug in y root 2. And then we can bring down the x, bring down the y, and root 2 times root 2 is equal to 2. So the area is going to be equal to 2xy. Earlier we showed that xy is equal to 12. So in the place of this xy, we can plug in 12. 2 times 12 is equal to 24, and now we're done. Let's give it a label of square units and put a box around it. In this given diagram, the area of the larger rectangle is equal to 24 square units. It's exactly double the area of either of these two rectangles. How exciting. And here's the next puzzle. We're given that the pink rectangle and the blue rectangle have the same area. And it wants to know, what is that area? In the diagram, we're also given that this connects these two vertices, and this triangle has an area of 12, and this triangle has an area of 3. This looks like it'll be a fun one. How exciting.